A very good day everyone. We welcome you to the massive open online course on cartographic techniques. Today's lecture we will be discussing about thematic mapping techniques, and the technique that we will be looking into is the Choropleth mapping technique. So the previous classes you would have studied about lot of techniques such as slope analysis, climate analysis, you would have studied about projections and everything. Now we are going to jump into the basic mapping techniques. So what we will be discussing today is basically what is a Choropleth map, and then we will see what is the procedure to create a Choropleth map, and then we will see one small experiment or one small exercise that is related to population density map of India, and then we will see what are the major points that we should remember. Okay. Now what is this Choropleth map? So it represents information through shading or coloring of predefined geographic areas. So we know that maps are a very important part of our day-to-day endeavor. Now there are different types of maps which you would have studied previously. Now this thematic mapping technique is nothing but we try to map the information based on a particular theme, and out of that particular theme, the Choropleth mapping technique, when we see that, it is basically trying to shade or color the maps based on your particular variable. So there are n number of variables, there are n number of information on the world around us. We try to map that to a specific geographic area. So that is the key point here. We try to map it to a specific geographic area. So now each area is shaded or colored in proportion to the variable being represented. So like I said, first what we are going to do is we are going to shade or color a geographic area. Now like I said, you are going to have a particular variable or you are going to have a particular theme. Based on that theme, you will be doing the coloring. So when we talk about these themes, there are few examples. So we can consider the demographics, we can consider the economics, health. So for a very good example will be when we would have seen a lot of maps that are related to the COVID-19 cases, where there is higher impact of COVID, where there is lower impact of COVID. So we try to map it with the geographic maps such as geographic areas such as your political boundaries. We try to map it based on the district, we try to map it based on the states, global level we try to map it. So all these are few examples of your Choropleth maps. So Choropleth maps can be applied across all these domains. It can work across your demographics, it can work across your economics. So if you want to study what is the poverty level, or if you want to try to see how is the air pollution level, so all these places your Choropleth map will play a major role. Okay. Now why do we need this Choropleth map? What is the use of this Choropleth map is basically we try to do good spatial distribution and pattern. So we try to understand the good spatial distribution and pattern in your data or in your variable. So there are a lot of studies where how the opinion of people are changing, how the demographics is changing. All these studies we try to see something called as clusters, whether there is a grouping of opinion, whether there is a grouping of any economy related issue, whether there is a grouping of any issue that is related to the environment or health. So this grouping or clustering we try to understand it with the help of this Choropleth mapping technique. Okay. So now I will show you few examples over here. So one example that you are seeing now is the population map of the United States based on the 2022 data. So when you see this map, what you try to do is you first try to understand what this map is trying to convey. So very major or very important thing is your legend actually. So based on this legend we can try to infer what it is trying to say. So what it is trying to say is the brown color patches that you are seeing, the brown color patches are representing a population that is nearby 20,000, and the dark blue color patches are trying to represent the information that is the population that is near to 5 million. when you are seeing the map, what I can understand from this, the initial understanding from this is basically I can understand that the central part of US, the population is a bit low, and when I see on the extremes, that is the left and the right extremes, I can see few states that are, few counties that are actually forming the a good grouping of a higher population. Now this is related to what is the kind of economy or what is the kind of facilities that are there, what is the kind of industries that are set up, and so all, I think the major cities of US, all these will be found over here. And one more thing is you can understand is, so this side you actually have the ocean, so what happens is you see good groupings that are around the ocean because that will be helpful for your trade. So again, from this Choropleth map based on the population, this is my understanding. The next one is a small example that is related to the US hourly minimum wages. So what is the minimum hourly wages in US across the different states? So these are the different states in US. How is the hourly minimum wage changing across US? So this is again one information that is related to the economics. So if you see this also, again you see California, obviously it has a very higher pay over there, and again you see few good groupings along these patches over here. So you see a good grouping which is saying that the value, the hourly pay in these areas are a bit lower. Now when we try to correlate with the tax patterns in US, when we try to correlate it with the kind of industry setup in these areas, it makes some sense over there. So again, the way we interpret the information based on a particular variable. So till now I showed you two examples, right? So one variable was population, which is a demographic variable. Then the next variable is your hourly wages, which is your economic variable. So these variables, we are taking it, we are putting it in a geographic area or a region. So mostly we say something as polygon features. So Choropleth mapping works very nice with polygon features, or features that have area. So it can be ward, it can be constituencies of MLAs, MPs, it can be your taluks, it can be watersheds. So anything that has a geographic area, when you try to take a variable, when you try to put it on top of it, and when you try to visualize that information using a technique, that becomes your Choropleth mapping technique. Now how do I do this Choropleth mapping? That is the next question. So what are the steps or what are the basic procedures that are involved in your Choropleth mapping? And sorry, before going to the procedures, I will also tell you what are the key features. So like I said, we discussed about the geographic boundaries, that is one thing. So I said districts, states, wards, you can also have, see, you can have MP constituencies, you can try to see how good a constituency is performing, or you can try to see how good the information is being, or how good the facilities are over there. Those things you can try to map, you can try to see what are the some kind of patterns over there. Similarly, next to the geographic boundaries, like I said, you should have something called as a variable. So that variable can be any information around the earth. It can, like I said, your pollution information. There are very nice informations that are being mapped nowadays. So that information is completely related to you. You can also try to see how the opinion about a cricket team is varying, how the opinion about a football club is varying around the country. So there are a lot of things that you can map, but the key element is your variable, and the other key element is your geographic boundary that you are choosing for your study. And the next thing is going to be your color gradient. So generally we try to define a color like we start with a very light color in the bottom that indicates a very lower value or a lower impact. So whenever the values are a bit low, we try to indicate it with a lighter color, and then when you have higher values, we try to indicate it with the darker colors. So even in the previous examples, if you see the blue colors, see lighter colors, they represent the lower value, and the darker colors you see, they are trying to represent the higher value over here. Even this example you can see. So here it is a different case where you have extremes are brighter, and in the center you tend to see a bit of lighter colors. So it is completely up to you how you define, but then you should understand that color gradienting is a very important factor over here. So those are the key elements, like I said. Now what we are going to see is basically what is the procedure. So if I have to do a Choropleth mapping, what are the procedures I should remember, how I should go ahead with my Choropleth mapping. So that is what we are going to see. Now in terms of your procedure, the first and foremost thing that you have to do is trying to select your variable. Okay. So what is the variable, whether it is going to be an economic variable, whether it is going to be an health related variable, you will choose your variable first. You will understand that variable, you will understand the data in that variable first. So that is the first topmost priority thing that you will do. Now next to understanding what is that variable, we have to try to determine the number of classes in that variable. So when I show it as an exercise, you will try to understand, but as of now you just remember what is the steps alone. So first I will select my variable, then what I will do is I will try to determine the number of classes using a technique which is called as the Sturge technique. Now next to identifying the number of classes, next what we do is we try to find what is the class interval. So when we talk about classes and class interval, it is nothing but I have a variable. Now how I am going to divide that variable and represent the information. So that is basically your classes. So I can divide the information into, let's say, for COVID cases impact. So when we talk about COVID cases impact, which and all countries have a higher impact, which and all countries have a moderate impact, which and all countries have a lower impact. So you can try to bring it like this, see, high, moderate and low. You can also have n number of classes. You can also see, you can just add, see, very high, high, moderate, low. It can also be related to some kind of values. So you can have values such as, see, 0 to 10. So let's say population density, let us take that example. So 0 to 10% per kilometer square. Then you can have 10 to 20, 20 to 30, then 30 to 40, then above 40. So these are the classes, like how many classes. So here I have 1, 2, 3, 4, 5 classes over here. Similarly here I have 1, 2, 3, 4, 5 different classes I have. So how many classes I am going to split my variable. So this variable into how many classes I am going to split, that is one thing. Next thing is your interval. Now here you see this example, if you see, the interval is 10. In a similar way I can also have a class interval of, let's say, 50 also, 0 to 50, 50 to 100, 100 to 150. So you can have the interval between your values. So your variable will have some values. What is the interval I am going to keep for every class? So that is your class interval. And then what you try to do is, based on this class interval, you try to categorize your geographic area into each class. So you categorize your geographic area into each class. So which particular district falls under class very high, which particular district falls under the class of high, which particular district or taluk or state is coming in the class interval of 50 to 100, which particular state is coming in the class interval of 10 to 20. So this is the question you will ask. So you will choose your variable, define your class, then you will go for class interval, and then you will ask this question, which district is coming under which class interval group. After that what we do is, based on this grouping, we try to define good color gradients, and then we try to map that particular information. So these are the 5 things you should remember. I will just quickly repeat: select your variable, then define the number of classes, then define your class interval, and then you try to map it or you try to categorize it, and then you do your color gradient. So this is the basic procedure involved in your Choropleth mapping. So one exercise that we are going to do today is, we are going to try to create the population density map of India based on the 2011 census data. So, we are going to create the population density map for India based on the 2011 census data. So, this is the task that we are going to do today. So, you have to just follow me as I do. Okay. So, like I said, the first thing is your variable, and I have chosen my variable which is my population density. So, this is the variable that I am choosing. Now, for population density, the formula is population density equal to the total population divided by the area. So, the total population divided by the your area is your formula for calculating the population density. So, now I have the list of states over here. So, we are going to do the population density map of India on a state basis. So, based on the states, how is the population density varying? So, that is what we are going to see today. So, I have the states, I have the state codes with me, two things, and like I said, you have the information of population and you have the information of area. So, before going for any mapping or any kind of task, you please check whether your particular variable has the right information and if that information is taken from the right source or not. So, those things are your preliminary steps. So, based on the accuracy of your variable, your map will try to represent the truth. So, here I have my population and my area. So, let us say Jammu and Kashmir for example. So, 12541302 divided by 222299.118. I will just quickly put this calculation in this thing calculator. So, see, you have 1 2 5 4 1 3 0 2 divided by 222299.118. You are getting an answer of 56.41. Okay, so you get an answer of 56.41. Now, in terms of population density, you should understand that you cannot have decimals because there is going to be no half people. A person is considered as one single person. So, you always need whole numbers in population density. So, this is also a crucial thing. What is the data type? What type of data I am going to represent? That is also a very important thing. You can have numbers, you can also have opinions, all these things you can have. So, here you see 56, I have rounded the value over here. So, in a similar way, you can try to create this particular table in your notebooks or anything. You can try to create this table and then you can try to do the calculation for your population density. So, in a similar way, I have done for all the states. Okay. So, now we are done with the population density. You can also try calculating it. You can also take this example also with you, but just try practicing it. Now, the next one, the second one is your determination of the number of classes using the Sturge's method or technique. So, this is your second step now. Now, the formula to do this is basically C is equal to 1 plus 3.322 multiplied by log n. Now, what is this n? It is the number of states, which means it is the number of geographic area or number of geographic entities that we are going to represent the variable. So, when we talk about districts, then we will have higher number of districts. So, this n will change. When we talk about states, since we are working with the 2011 census data, we are going with 28 states over here of India. We are not considering the union territories, we are just considering the states. Since this is a small example, we are just considering the states alone. And now, next, what is C? The number of classes. So, this whole task, the second task is to identify the number of classes. So, C represents the number of classes. So, C is equal to 1 plus 3.322 multiplied by log n, and the number of classes that I have derived is 6 classes. I will just quickly show you the calculation alone. I will just quickly show you the calculation alone. So, you can change to the scientific calculator. You see over here, you select 28 log, see you get 1.44, which I have rounded to 1.55 over here. Okay. So, this one again you try to do a multiplication. So, your 1 plus 3.322 is 4.322. So, 4.322 multiplied by your 1.45, which is equal to your 6.26. So, 6.25 I have rounded it to 6 different classes. So, based on all these calculations, I am going to say that for my population density Choropleth map that I am going to do, I am going to define 6 different classes, and this is based on your Sturge method. Now, next to your determination of classes, we will go to what should be the interval for each class. So, determining the class interval. Now, the formula for class interval is basically the highest value in your data set minus the lowest value in your data, which is your population density in this case. So, what is the highest population density, what is the lowest population density, you should take it from your data, and then you have to divide it by the number of classes, which is basically 6 for us over here. So, when you move to the next step, you see the highest value or the highest population density, you find it as 1106 from the data, and the lowest that you see is here this 17, Arunachal Pradesh is the lowest, and then Bihar 116 will be your highest density. So, yeah, so 1106 minus 17 divided by 6, you get 181. Now, in terms of this class interval also, we would like it to be a bit rounded. So, whatever value you are getting, you try to round it to the next nearest greater value. So, you can also have 185, but I felt 190 is kind of bit easier to do the breakup. So, I went with 190 as the class interval. So, which means for the 6 data sets that I have, I am going to break it based on 190, 190, 190. So, I will show you how I am doing that in the next step. So, the categorization of the state code into each class. So, now 6 classes, I know what is the interval that I should look for, and then I will do the categorization. So, now when you see this particular table, you will see that you have a class boundary, 6 class boundaries, see 1, 2, 3, 4, 5 and 6 different class boundaries you have. So, what we do is, see, we set a class less than, so 190 is the class interval, right. So, this is like 0 to 190, that is why I have just mentioned it as less than 190, which means 0 to 190. Then you have 190 to 380. So, 190 to 380. So, when you just add 190 over here, it becomes 380. So, it is 190 to 380. Similarly, you add another 190 over here, you get 380 to 570. Again add a 190 over here, you get 570 to 760. Then again 760 to 950, and after that the 6th class will be anything that is above 950. So, the highest value is 1106 here. So, till 950 to 1106 will be your 6th class. So, class 1, 2, 3, 4, 5 and 6. So, 6 different classes we have split based on the class interval that I got from my previous step. Okay. Now, I have got the class interval. So, I know what is the class boundaries and I know what are the number of classes. Now, what I am doing is, see, for each and every class boundary I am going to go and check what is the state code or what is the state that is falling within this boundary. So, now this 0 to 190, 190 to 380, 380 to 570, all these things are nothing but your population density range. It is your population density range. So, I hope you understand that whatever work we are doing is we are working with the population density data over here. So, see, whatever value I am taking only the population density value over here. See, this highest value, lowest value, everything I am taking it from the population density. Okay. So, I am taking it, I am creating the number of classes and then I am going for the class interval, and after class interval I am trying to categorize this data. So, what I will go and see now is what and all states are having a population density lower than 190. So, what I will go is I will quickly go to my table and then I will try to see what are the states having a population density lower than 190. So, see the density here 1, this is lower, this one is not included. So, 188 I have, 190. So, this one, and then similarly this one, this one, this one, this one, this one, this one, sorry, not this one, not 352, 132. See, 189 will come, that is it. So, the number of states that have a population density lower than 190, I will note down the state codes over here. The next one for, I will just quickly move. So, we will just see for 570 to 760. So, there is only one state code which is 6. You go to the table again, you search for state code number 6. So, see Haryana, only this value will be between that particular range which is 570 to 760. So, state code number 6, and you are giving the gradings also over here. So, you are giving 6, 5, 4, 3, 2, 1, and when we are mapping this, no, this will exactly turn into reverse. So, whatever is having the highest value, it will get mapped with the darker color. So, this value is important and this grading is also important over here. So, you have given the grades. Now, what you will do is just see, you will just add this grades to the respective state over here. So, you are just adding the grades over here to the respective states. So, like I said, see Jammu, this density is 56 will have the 6th grade, all these will have, and in the case of Haryana, see this will be in the 3rd grade 575, and Punjab, see 550, it is falling in the 4th grade. So, you have to just remember the range, you remember the grade, and then you just try to fill up these grade values over here. So, similarly for all the states I have filled what is the grade value. Okay. Now, I have got what is the grade value. Now, I know the 6 different grade values over here. So, now I have a political map. So, see, I will just put the values over here for a reference quickly, 190 to 380, 380 to 570, 570 to your 760, 760 to 950 and above 950. So, quickly you see here what and all is having a value that is above 950. So, let us take this example of West Bengal. You take the example of West Bengal, you have a value of 1070, right. So, what you do is you go to your map and then you shade it with the darkest color that you have. So, you have to shade it with the darkest color that you have. You have to shade your West Bengal. We will see an example on the lower side. So, on the lower side, let us take your what can we take? Let us try to take, okay, let us take Jammu and Kashmir itself. So on the lowest side we will take Jammu and Kashmir. So this one you try to very mild, or even white is fine. Actually you can also try to put it up with white color. White will represent the lowest value over there, and then you can also take one in the mid range. So we will try to take something like, let's say for example, let us take Tamil Nadu. So it is in the category of fourth category, right? So the fourth category, you can take a mild color and try to shade it with a milder color. So this color ranging, it is completely up to you. So but then it should be a good representation, it should represent it in a nice way. So one example I will quickly show you, or how the expected outcome should be, I will show you. This is how we expect the outcome. So see, from lighter shades, you see lower values, I said no, will have lighter shades, and the higher values will have the darker shades. So your final output that you try to map, it should look something similar to this particular image that you are seeing on the slide. So this is what we expect from you in terms of a Choropleth map. When I look into it, what I try to understand is basically towards this side, kind of northern side, you have a higher density of population, then the middle portions are somewhat subtle, they are in this particular range of the second and the third grade. So and again Kerala is showing the bit of higher population density. So this is a very simple example, and we have done a very simple inference with this particular example. So to wind up this particular session, we will just see what are the major points to remember. So like I said, your Choropleth mapping is nothing but it is trying to shade geographic areas based on a particular variable, which can be your demographics, economics, health, and n number of variables. So the steps is basically select your variable, then you go for the number of classes, then you go for the class interval, and then you come for your color gradient based on the class interval. And it basically what it does is it helps you to understand different kind of patterns. So with that we are closing the Choropleth mapping. So thank you everyone.